Hello, welcome to chapter 11. Again, we're going to part 2, continuing on with the function of the eye. When we left you with the eye last, we were talking about the way the eye focuses. The eye is focused based on moving the lens, and the lens is moved by the lens is stretched and flattened by this circulatory muscles and papillary ligaments. As the muscles contract, or as the muscles change, it changes the shape. As you get older, this lens loses its elasticity, and that's when you need reading glasses, because if you lose your elasticity, you're unable to change your eyesight quickly, or the field of view quickly, and also unable to see things close up. Okay, when we look at some eye concerns, the shape of the eye and the way the light's refracted will create two very common conditions. One is hyperopia, hyper meaning more, so you're farsighted, and then you have myopia, which is nearsighted. Hyperopia is a result of a short eyeball or too curved of a cornea. And as a result, the light is bending too much and focusing behind, the light is not bending enough and is focused behind the eyeball, behind the retina. So what you do is you will take a convex pieces of eyeglasses, and as a result, it will cause the light to bend more. Notice when the light focuses on the back of the retina, it is upside down, and the brain has the ability to change this process and to readapt. Hyperopia, the light focuses behind the eye because the eyeball is too short. Myopia is the opposite condition, where it is nearsighted because the light will focus in front of the retina because your eyeball is too long, and that is one of my eye problems. I have long eyeballs. What happens there is you're given concave reading glass or concave glasses. The concave glasses will spread out the lens, so this way they focus on the retina. In a perfect world, on the fovea centralis. There's also a very common disorder called retinal disorders. If you detach the retina, it's not at that perfect length in order for it to be focused on. There's also a condition called presbyopia. Presbyopia is the lack of the eye contracting. So, oops, not that one, this one. We have hyperopia, where you're farsighted, your eye is too short. Myopia, you're nearsighted, your eye is too long. Astigmatism is a result of the cornea not being equally round, and as a result there's a bumpiness that is corrected by having an extra focal change in your glasses. Then we talked about astigmatism. We're not going to talk much about convergent, divergent, and amblyopia. Those are just different eye conditions. I'm just mainly focusing on the area with of refraction because those are easy corrected, and if you look around, most of us have glasses. Okay? Easily corrected. And that's pretty much all you need to know from the eyeball. Please focus on the fact that there are muscles. You don't need to know the name of the muscles extrinsically. Intrinsically, you need to know the iris and the ciliary muscles. And then we don't normally focus too much on diseases and conditions, but I want you to focus on nearsighted, farsighted, and astigmatism. Good. Let's look at the ear. When it comes to the ear is used for hearing. There are 3 parts of the ear. You have the outer ear, which mainly collects it and channels it into the tympanic membrane or the eardrum. You have the middle ear, which has the ossicles, malleus, incus, and stapes. They spell miss. They are the bones of your ear, which will magnify the sound about 20 times because of the leverage of the shape. And it also conducts it because what happens, the pinna collects the sound, The sound will then cause the tympanic membrane to vibrate, and those vibrations are magnified by the malleus, the incus, and the stapes. So the middle ear ossicles will magnify and transport the sound. Then it will go to the inner ear, and on the inner ear you have the cochlea, which is the hearing organ, and you have the semicircular canals, which are used for equilibrium. Please notice you have the eustachian tube or the auditory tube. Sometimes it's called the pharyngotympanic duct. This is used to equalize the pressure. You may notice when you go up in an airplane, your ears, the extra pressure on your ears causes pain, but chewing gum will help get air up into there so it will be equalized, or even swallowing. I have to be a big gum chewer, okay? That is how the ear works. So external ear collects the sound. Middle ear will magnify the sound, amplify the sound, and transmit it. You need to know the ossicles, malleus, incus, and stapes, spell miss. Okay? Then when you get to the tympanic membrane, after the tympanic membrane, you get to the, I always mix these up, oral window, I want to say. And then it comes out the round window. This is the inner ear. The inner ear basically is a bony labyrinth. And all of this contains, transmits the sound waves, and this sound waves are then transmitted and transferred into sound impulses. So when you look at the cochlea, here's where the bones go. Here is the oval window. Then the sound will cause this one. The sound will cause the tectoral membrane to vibrate. As this membrane vibrates, it will stimulate hair cells, and the hair cells are connected to nerves, which will then pick up the sound. Now, with hearing damage, especially if you're listening to loud sounds, or part of your hearing range will disappear because you have damaged the hair cells. As you go around the cochlea, it's a different thickness, and just as different thickness of chords vibrate at a different sound, if you know about guitar chords or piano chords, different thicknesses of the membrane will vibrate or resonate at a certain frequency. As it resonates at this certain frequency, this will stimulate the nerves at the frequency. A lot more information here, but that's pretty much what you need to know about sound. The sound waves come in the oval window, cause the vibration in the tectoral membrane. That'll be picked up by the hair cells, and then the extra sound will exit via the round window. Okay, all that sound is transferred. It used to be called the auditory duct, but this is called the vestibule and the cochlea. So this is the vestibulocochlear nerve, nerve number 8. Okay, so when we look at sound, sound starts from the external auditory canal. The tympanic membrane or the eardrum vibrates. The ossicles will transmit the vibrations across the inner ear, magnifying. The stapes will then vibrate the oral window, and it'll cause the inner ear to vibrate. As a result, those vibrations will travel through the fluid or the perilymph, and the spiral organ hair cells will vibrate against the tectoral membrane at certain frequencies, generating nerve impulses. These nerve impulses will travel via the cochlear nerve to the cerebral cortex or the temporal lobe cortex, where they're interpreted. Then the sound waves leave the inner ear via the round window. Okay? So the inner ear is used for sound, but it's also used for equilibrium when you look at these semicircular canals and the vestibule. You have two types of equilibrium. You have a circulatory, two types of receptors. We're going to look at the macula and the cristae. When you look at vestibular equilibrium, which is this part here, this is the equilibrium of the up or down, or the gravitational equilibrium. The semicircular canals are used for circular equilibrium. As you move your head up and down, there are these little stones called otoliths in your fluid. What happens, it will cause these cilia to bend. The bending of the cilia will send messages to your brain. So that is for gravitational equilibrium and balance for your head. When you're spinning, you have cristae, or these little projections inside your semicircular canals. And when you look at your semicircular canals, there's sort of three of them, one in each plane. As you move in whatever direction, you will cause the fluid in these to move. That will bend your cristae in a certain way. As you bend your cristae will then send messages. Now, a way to get dizzy is when you stop moving, your fluid in your semicircular canals may still be moving, and that's how you can get dizzy or how you can get vertigo. And that is how the ear works. In terms of ear loss, notice you have a lot of otis problems. We're not going to look much at ear infections or hearing loss, other than to put it into three categories. You can have a conductive hearing loss, which means the messages are not being conducted usually through the bones to the cochlea. You can also have, and this can be fixed with a cochlear implant, you can also have a sensory neural loss, which means the nerve is not carrying it. Notice there is a presby word in there. Anytime you have presbycusis, like percussion, pres means old, so this is losing your hearing because you're getting old. Usually what happens is either your tympanic membrane isn't functioning properly if you have a burst eardrum, or you're wearing out those hair cells, those very important hair cells. Not in that diagram. The hair cells, which are, where are they? Right here. The hair cells right here. As you wear them out, they won't replace. And this is one of the problems of having your iPod on too loud. These are sound waves. Sound waves are mechanical waves. They're actually compressing the air, so having them too loud will cause problems. Okay? You do need to know details on hearing, and you do need to know how the two different types of equilibrium are established. Good. When it comes to other receptors, we have taste receptors, and your taste receptors are basically into five categories. Sweet, which is on the tip of your tongue, salty, which is on the side, sour is on the back, and bitter is on the very back. And umami, I'm not sure, I don't remember that one. You have a nerve supply. You just need to know where they are. You don't need to know too much detail. Then you have smell. Smell has to do with olfactory bulbs up in the top of your nose, but it is also related to your sense of taste is also related to smell. That's why when you have a cold, you can't taste food. Then there are general type of receptors. There's a heat receptor, a cold receptor, a pain. Touch could be deep, and a pressure receptor. You just need to know these. We won't go into too much detail in terms of that. Paying attention to word anatomy, you have ophtha, like ophthalmologist. Presby means old. Tympan means drum. Auto, like an otoscope, is the thing to look at your ear. Proprio has to do with perception, and alges has to do with pain. And that is the end of chapter 11.